Hello everyone, this is our senior year project, SkyBound, drone with a toroidal propeller. I'm Ebru Kapucuoğlu and these are my teammates Selin, Alkan and Taleh Aliyev. So in our project, our aim is to minimizing the noise emission firstly, improving flight stability, enhancing flight efficiency, and lastly, develop toroidal propeller designs. So this is our drone frame. We did it on an X-shaped skeleton, and additionally there are some parts like power distribution plate, flight controller, a 4 ampere electronical flight controller, speed controller, 1000 kilovolt brushless motor, LiPo battery, and a GPS tracker, and most importantly, toroidal propellers. So these are three body approaches. Firstly, we aim to design a new whole body at the first and the second approach, but we failed. And lastly, we build it on a skeleton that we succeeded at the end and had a successful flight.
In this process, we designed 5 different toroidal propellers. These first two for the first drone body approach, they were inadequate and weak material, so we couldn't test them in real life. Sample 3 is for the second drone body approach. It has a strong material but weak central connection. Sample for the third drone body approach. It has a strong material, however, inadequate central connection. It was not suitable for our drone. And sample 5 is for the third drone body approach, and it is our final toroidal propeller. It has a strong material and strong central connection, so it was compatible with our drone body. And here is the pitch value calculation. In designing process, we used pitch value calculation for the efficiency and thrust value for the propellers. Equation 1 shows the formula of the pitch value, and down below shows the calculation process of the pitch value, which is 22 degrees.
So after designing the propellers, we have decided to conduct some ANSYS static structural tests. And in the maximum principal stress, we have some results about 105 megapascals. This shows us the propeller stays within elastic limits during normal flight. Coming to the total deformation of the propeller, we see that approximate maximum displacement of about 14.52 millimeters. And outer deformations are expected, but the structure is generally safe in the short term. So in asset analysis, we got 105 megapascal stress, which has resulted in a drone operating within elastic limits. And the specially designed drone using toroidal propeller, control integration with 60% thrust force, and electrical and mechanical operation of the system have been approved. The resistance of PLA, resin, and carbon fiber reinforced PLA materials to thrust force has been analyzed, and it has been determined that the most suitable material in the material analysis is carbon fiber reinforced PLA. It has been also observed that the open drone body design has advantages over the closed drone body design in terms of center of gravity distribution and system part connection. In the future, we are planning to integrate the hybrid manufacturing to be more durable and efficient, also improving and increasing autonomous operation settings, such as adding cameras and LiDAR sensors are one of these plans. And also we are planning to optimize the battery for flight duration improvement. And lastly, we're planning to develop a self-check mechanism that detects damaged parts. Thank you for your listening.